All right, so every time I'm doing this, and I haven't done it in a while, it's like I have to learn over what I'm doing. So I hope I'm doing the correct thing here. Um, exam is in a bit. Exam is maths is on Wednesday or Thursday when it's maths. January the 4th. Right now in January the 1st. So 2-3 days away from now. So I'm just touching this to, it's the first day of the year. Yes, well done, Jabish. First day of the year. I get in my channel ready to let my channel know that this year is going to be a lot of this. So, channel, get ready. Understand. We're going to be in a lot this year. Good night, Renel. Good night, Talks. Happy New Year, Jabish. Happy New Year, Samantha. J. Tassi. What's up? Happy New Year, Lenisha, Tristan. Happy New Year, everybody. First day of the year, 2024. So what topic giving you all problems? So let's just jump into this. What topic? I was just revising a video on function speeches. Nice, nice, nice. What topic are you concerned about? What is the topic you're concerned about? I'm not in Trinidad right now, but the maths must go on, Geometry. Someone said bearings. Someone said geometry. Understandable. Bearings. Let's do bearings. Getting on top of bearings is sometimes an issue. So maybe I can give you a little talk on bearings. I see that I have Tuesday and Wednesday to come online and try and do something as well once time permits. So let's do a little bearings and then we'll pick another topic right now. Bearings is an interesting topic to do because it's one of the hardest topics in the exam, like the hardest topics. Like I forget how to write, but when you come back to school after holiday and you forget how to write. Some students brace themselves for some interesting handwriting. Hardest topics would be like bearings. What are the hardest topics? Hardest topics, bearings. If only hearing crying in the background, that's 0, right? We have linear programming, probably the hardest topic there is. We have vectors. Students get a lot of trouble with vectors. We have completing the square, and we have matrix transformation matrices. So these will probably, one of these will be the hardest things you all will see in the exam. So, and someone asks to do bearings. So we're going to look at bearings. Now, today I'm reviewing it from a understanding the concept of the topic kind of perspective. May not even load up a past paper. We'll see. But you'll let me know how it's going, right? So when we say bearings, and there's nothing prepared. I'm just speaking from the top of my mind, like if I'm revising and I'm helping out somebody last minute understand what bearings is, right? Some of the things that I need to remember is that bearings is really about angles. It's really about angles from the north. It's really about angles from the north. So like, okay, like if there's a ship here, they love to use ship. There's this red ship here. And then there's this blue ship over here. Blue ship, right? What is the bearing of the blue ship from the red ship? That's a bearings question right there. Now, if it's blurry on your end, you just need to raise the settings on YouTube. It's 2024. We had to know these things. If it's blurry on your end, you just need to raise your setting on YouTube, right? So that's my question. Here's my question, guys. So what is the bearing of blue from red? What's the bearing of blue from red? That's a simple question. If you understand bearings at a basic level, you're hitting that, you're knocking out the park one time. So you could just go in the settings and change the quality, right? If you're seeing any problems. What is the bearing? Anyone? It is 90 degrees. Shakira said it. And she needs to put 090. So we normally write this. So the answer for this will look like 090. 090. Right? You could put the degrees as well if you want. And if I change this around and ask what is the bearing of red from blue, what would you see? What is the answer? So you get the answer for the first one. What would be the answer for the second one then? What is the bearing of red from blue? So I'm going to explain why it's 90 degrees. If you remember thinking, why in the world is that 90 degrees? Okay, you see maybe it's at 90 degrees, but I'm going to explain why. So the next answer, Shakira got it as well. Shakira and Lorenzo know the thing. They're saying 270. So they're saying this one is 270 degrees, right? Well, remember, bearing speaks about the degree of turn something has to be, like the blue ship from the red ship. So the key here is understanding that when you use the word from in bearings, you have to look at the ship, the port, the item, the location that comes after the word from blue. So in the first example, I said from red. It's like if I'm here and I'm asking you what direction, because I'm on red, right? From red, what direction is blue? Well, bearing is from the north. It starts at the north and it turns in a clockwise direction. Listen to this very carefully. It turns in a clockwise direction until it reaches the line that connects the two locations. So what's that angle? What's that angle? That is 90 degrees. It's 90 degrees. Or no, if I were to do the other way, what we had the red. We had the red ship over here, right? And then we had the blue ship here. And I asked the bearing, and in the second question, I asked the bearing of red from blue this time. So it means I'm starting on blue. And how do we work on the bearing? We draw the north at the first location. You connect the two locations together. And you go clockwise from the north until you hit the line that connects the two locations together, which is 270 degrees. That making sense? You seeing it? You seeing it? All right, let's set up some more questions. Before I set up some more questions, there's another item that you should understand with bearings, right? So there's a lot of items to understand with bearings. There's this situation that shows up and will show up in your exam, guaranteed in some way or some form or fashion, if not this week in the paper one. There are two parallel lines. These I shouldn't say two pair of parallel, I should say a pair of parallel lines. So the sticking board sticking it, them thing that still happen. Let me see. Try again. So you have a line, two lines that are parallel to each other. So you call them parallel lines, right? And we're gonna draw a line right straight down like this. Matter of fact, I don't even need to draw it straight down. I could draw it at an angle like this. And it's going to create the simplest way to understand it, and this is tied into bearing, stay with me, the simplest way to understand it is that it creates two identical positions. So this position here is identical to this position here. And what does that mean? That means this angle has to be equal to this angle because it's in the same position. All the angles in the same position are equal to each other. Which means this angle below here, what's in this position now, right there? So the red angles are equal to each other. This angle, if for example, if this angle was 70 degrees, guess what? This is also 70 degrees. This is also 70 degrees. This is also 70 degrees. And we have names for them, and you should know their names. These two are called corresponding when you look at the angle that corresponds with the position in the next spot. These two behind each other, Taisana said it, or I'm sorry, Tassi said it. They are vertically opposite because they're right behind each other. So that just means behind each other, right? Vertically opposite. Well, we are good with the people here. What's the time in Trinidad right now? Where I am, it's 8:41. It's 7:41. So it may be 8:41 in Trinidad. So vertically opposite, right? And there's also stuff called alternate. So let me show what alternate would be. Like this 70 with this 70 below here, they are alternate to each other. And if I draw an angle here, what is this angle going to be? This angle is going to be, well, how do we figure out what that angle is? Well, remember it's a parallel line, and on a straight line, there's a complete angle of 180 degrees to make the line straight. So if the line is straight, it's 180 degrees. And this is 70 degrees. It makes sense that this is 110 degrees, right? To make up the 100. Yes, Zane. So now, similarly, if this is 110, behind it, vertically opposite is 110. Corresponding with that, this will be 110. And alternate to that, which is also vertically opposite to this one, it's 110 degrees, right? So I'm seeing some people mention the word co-interior. I didn't show you anything that's co-interior yet, you know? Just saying, So this angle and these angles are not co-interior. We don't use the word co-interior. We just say angle on a straight line add up to 180. So what is the co-interior? Co-interior deals with, let me show you which two would make co-interior angles, right? See this one with this one, that's co-interior. Notice how they kind of in one kind of trapped area here. You seen it? Notice how they're in a kind of trapped co-interior. That's what we mean when we say co-interior. So this piece of knowledge here shows up in quite a few things. It shows up in bearings. So this shows up in bearings. You can see it in just little basic ideas in bearings, and it can show up in a multiple choice, like as a topic alone. It can show up in basic trigonometry. It can show up in circle geometry. So you must understand this. You must understand this little topic that we draw here. So we established earlier, because we're trashing out bearings right now, right? We're trashing out bearings. We established earlier that bearings is really just an indication of direction between 2 points. Like if maybe there's a point here and there's a point here, A, B, and I ask you, what's the bearing of, let's draw some angles. And I'm going to ask you something, right? Let's see who understands it best. Let's see who understands it best. Let's call this theta 1. Theta is a symbol that we use to talk about angles, right? Let's call this angle here theta 2. Let's call this whole big angle here theta 3. Let's call this whole big angle here theta 4. So there are 4 angles in the question. Now listen to me, listen to my words. What is the bearing of A from B? Which one of the angles should you select? What is the bearing of A from B? Which one of these angles is showing the bearing of A from B? Is it theta 1? Is it theta 2? Theta, Theta, as you see, like X then for angles. Is it theta 3? Is it theta 4? Who is showing the bearing of A from B? The bearing of A from B. Well, the key is this word from. From B means you're looking at point B and you're starting at the north and you're going around in a clockwise direction until you hit the line that connects the two locations to each other. So a lot of you all got this correct. Congratulations, you're starting off the new year looking nice. All right, so it is theta 3. It is theta 3. So let's take this a little further now. Let's say I had point A here and point B there. And let's say somehow the question gave me that this angle is, what does that look like? That looks like 115 degrees. The question, there was a long, you know how these bearings questions go on with some nice long little paragraphs to hot up your head and you're like, wow, maths. So 115 degrees. They tell you that the bearing of B from E is 115 degrees. That's in the question, right? So if you draw your sketch, you have this. Now, they want the exact value of the bearing of A from B. Can you give me that answer? So this is like a classic part 1 in a bearings question. Can you give me that answer? What is the bearing of A from B? So what we are doing right now is just understanding the fundamental ideas with bearings. What is the bearing of A from B? So the question gave us the first angle here. So I'm thinking maybe you all just subtracted. But is just subtracting the best thing to do? Because most of y'all know what angle you're targeting for, right? You're getting a lot of 245, right? I get, let me call some names. I have Abraham, Leah, Simone, Raquel, Corey, Miss Ramen, Ramen. Put away the ramen noodles for the new year. I don't know. Tassie was one of the first ones out with it. And now I'm seeing some 285s, which I think, or 295. I didn't work it out in my mind or anything. But me, 245, I'm pretty sure is not the answer. Because I think a lot of you all know what you're looking for, but maybe you overlook something. Maybe you know this, that in a circle, complete circle, if we turn around, we have 360 degrees. So maybe you just looked at this and you say, okay, well, just subtract it from 360 and I'll get the angle here. But is that really so? Let's go and look and let's draw and see. So if I draw a north here, now this is one of the major tips in bearings. Write this down. For those of you all who okay in maths, maybe you're doing your maths past papers and things, and it's the bearings questions again. This is a big tip for, I'm talking for like middle to really good students. This is a big tip. You must draw your notes on all of a sudden you start to see things that you didn't see before. You draw your notes. There's a video I have on bearings right now on YouTube. You could go and look it up. That's cool. And from 2018, 2019, you can go and look it up. It's really good. It's still good. Now you realize this is the angle you're going for. Not so? That angle is not 245. So you can't just minus from 360. Why? Why? Because you need to realize that we're dealing with, firstly, co-interior angles. So my first job is to find this angle over here, which is, tell me if you understand that this angle is 65 degrees. Tell me if you understand why. See it? You seeing it? Because remember, these angles that trapped in a box like this, when the knots are parallel to each other, when they're trapped in that box there, they are called co-interior angles and they add up to 180 degrees. A fancy word for that is supplementary. We just did that. Look, the box here, seeing it in green? Notice this was 70 and this was 110. It adds up to 180. So that's how I knew that this has to be 65. And if this is actually the 65, when I go all the way around, this angle that I want, yes, that angle that I want has to be 360 minus the 65, which is why people get the 295 degrees. That's the bearing. So that's one way of viewing it. Another way of viewing it, sometimes this is the way you see it in the question. Like that was one way of seeing already co-interior angles. Another way of spotting the angle that you really want is extension. So that's the next step with bearings. It's very simple tips that go along with bearings. Draw your knots so you can, and always remember the knot lines are parallel to each other. So that's where the rules come into play. These lines are parallel to each other, right? So you can make co-interior corresponding, blah, blah, blah. And extend. Sometimes you may need to, here's what I mean by extend. Extend like this. Extend like this. And see if you see anything. Yes, I'm seeing another way I can figure out. Before I did this, I figured out this was 65. That's co-interior. Somebody asked about that, Sierra. So this is 65. And the reason being, it's trapped in this box here, meaning it's co-interior. That's the co-interior angle. Just to be clear, the knots are parallel to each other. So if I have two knot poles and I draw a line like this, these angles are co-interior. But these angles are corresponding. Now we've seen some corresponding angles when I extended. That means this is 115. So even if I wasn't able to spot the co-interior, I could spot the corresponding angle. Then I know that this angle here is on a straight line, it's 180. So I add the 180 and the 115 and I get 295, which is the angle that I'm looking for as well. Now this is usually the way you spot it in the bearings question. You know? This is usually the way. You extend, you see, oh, corresponding, and you see it this way easier in the question than the co-interior. But once you catch the hang of the co-interior is a little faster. But usually students in the beginning normally see it this way. How is that? What do you think? So let's create a next situation. Let's say we have a ship. That's the ship A. And then they said, no, let me see if I can put it in words first, and then you try and visualize it. Ship B is due 80 kilometers east of ship A. Ship C is on a bearing of 300 degrees from ship B. That's not, I'm gonna visualize this in my mind and see if this is making some sense. It is 60 kilometers away from ship B. So I want you now to, I just made up this out of the top of my mind. I want you now to, yes, so this live will be on YouTube forever and ever. People who watching this 10 years in the future, hello, as you see how things looking. We out here still. So I want you to draw, I want you to draw this. So let's say this came in the exam on, when is it? Tuesday on the 4th. And they told you that ship B is due 80 kilometers east of ship A, and ship C is on a bearing of 300 from ship B. It is also 60 kilometers away, and they want you to draw a sketch showing all the information. Draw a sketch showing all the information. Yes, Chelsea, you could extend the note line downwards. Sometimes that helps the question as well. So you should be finishing up your sketch if you are a real pro. If you are one of those persons who get dazed out and you miss the whole question, like, oh, he asked a question, let me repeat the question. I want you to draw a sketch giving this information and include all the information. 2 marks. 2 marks. Because you know CSEC and Maths, stingiest thing ever. So ship B is due 80 kilometers east of ship A. Ship C is on a bearing of 300 degrees from ship B, which is 60 kilometers away from ship B. So I ain't asking no question about to figure out no length and no line or anything yet. Corey, or I know you probably done knocking that down already. I just wanted to draw the sketch. All right, so I'm feeling like we have some sketch drawing across the Caribbean here. I'm going to draw my sketch. I'm in Atlanta right now, so we'll connect on some kind of bearings. So let me draw this sketch. So first thing first, I'll draw ship A. I already have an idea in my mind, right? So I know ship A could go here. If east, you must know your cardinal points, otherwise you can't even begin a bearings question, right? North is point up. In case you didn't know, north is point up. East point to the right. You know, the sun is rising the east, and west point this way, right? So west and east basically spell we then. And south, this may come as a surprise to you, but south points down. So north, south, west, east, right? Fine. So if ship B is due 80 kilometers east of ship A, you should have this on your paper. So yes, type yes if you have this on your paper. Type yes. You have the first part though. Yeah, you're in a one mark situation here already. Of course, you know, security bag and parallel n else here. You know that n mean that you're outline there. Yeah. So just to figure out ship C now. Well, to do ship C, you need to actually take out something called your protractor. I don't need to tell you what's your protractor, right? Protractor. So that's this circle thing that measures or draws angles, semicircle, by a protractor. So you need your protractor. And what you need is to measure 300. I can't really show you how to measure 300 right now. You have to measure 180. Then you come and you measure the remaining thing to 300. 120. And you draw that line going up like this. And then you want to measure. So maybe you add 8 centimeters to represent 8 kilometers. So you put 6. So C should look like this. This angle, I am sure, is 300. That's what you want. And you'll put a little note there. Why isn't it chat if you got all of that? Oh, wait, I didn't put the length of the line. This line is 60 kilometers. So most likely you will get a question in bearings that starts like this. And this is usually be where people start getting their problems one time. And some persons find it easy, some persons find it hard. I always notice this is one of those topics: measurement, bearings, geometry. Some people are able to see things in their mind better, like spatial diagrams, and some persons directions, north, east, bearings, they don't really show up in their mind. You need lots of work with it. That's okay. You just need to put in work. So 80 kilometers, 60 kilometers, And you're seeing how the 300, I took it from ship B. So I started on B. I got 300 degrees, meaning going from north. Bearings is from north, you go clockwise until you hit the line that connects the two locations you're interested in. I wanted C and B. I connected B and C and I hit that. So it's perfect. It's perfect. So that's how you can start off a bearings question and you get 2 marks. Or 3 marks. This one was a little complicated. 2 marks, most likely still though. Closer to the 120. It depends. I just guessing that's where 300 is. 300 would be, ship C might be somewhere here, could be somewhere there. I don't know. I didn't use that. You notice I didn't use that ruler and thing. I sketching here, people. So so where could this question end up? The most common thing they'll ask you after a bearings question is this line here. This line here, people. See this line? Them love this line earlier. This is where we introduce the main piece of bearings, the main idea in bearings. So have you ever completed an entire bearings question yet? Anybody? Do you have that badge? Do you have that badge? The badge of completing an entire bearings question? Correct. Correctly. So that is usually the first thing they're interested in. So how they'll write that is find the distance between A and C. And that'll be your job. It's going to be a very interesting job. So, how do we even begin to do this? How do we even begin to do this, ladies and gentlemen? So what I will do is I'll go through this entire thing, I'll decode it, and try to break it down and show you how I think about the question. And then for the rest of the night, this is mostly for the students who okay, right? You know, you already know how to do a quadratic equation, then you already know how to do basic matrices. If you don't know how to do a quadratic or basic matrices or algebra, this probably is not a video for you. You should go and be watching your quadratic something right now. So I'm going to decode this question, and after I do it, you're going to look up all the bearings videos I have, all the past papers you have on bearings, and you're going to try your best. Yes. So the bearings question. So I have a bearings question. Watch this, ladies and gents. A bearings question. B-E-A-R-I-N-G. Bearings deals with direction. It usually starts off with like you just find an angle, or you draw something, like how you see me draw something, you know, so I found an angle or draw something, which could be difficult. And then it goes into find a length, like what I'm asking you there. L-E-N-G-H-T. No longer trying to learn how to G-T-H. No longer trying to learn how to spell length confidently. And then you may have to find another angle. You see this part? This part is where you use the two really tough ideas in bearings. The cosine rule and the sine rule. So the cosine rule is usually regarded as like your toughest mathematical equation that you'll use for CXC. Cosine rule and sine rule. This is what I call this region advanced trigs. It's not really advanced trigs. It's advanced trigs for CSEC Maths. Advanced trigs is something else. That's like ad maths, pure maths. That's advanced trigs. But this is advanced trigs for CSEC Maths. Cosine rule, sine rule. So the kind of easy question, what is basic trigs then? So remember, I'm breaking down everything, right? So we have advanced stuff. We have basic, and then we have the beginner stuff. And this is trigs. Trigs is the idea with triangles, right? Trigonometry. So I'm going to break down what you need to know for CXC. Excuse the coughing in the background. That's my son. So I'm going to break down what you should know for trigonometry, and you tick off how much things you have done. So the beginner thing is like, my board is sticking. Let's see if I can refresh my board. Oh no, I have to draw the AC thing. So let me just snap a picture of this so I'll have it for later, because I'm going to use this later, right? So you can find AC. And I just want to refresh my board so I can stay with me, people. This is just going to take a split second. Well, 3 seconds. It's done. Yeah, so we have beginner trigs, beginner, we have basic, it helps to learn it like this, and we have advanced stuff. So I already told you all the advanced things in trigs will be like the cosine rule and the sine rule. Do you know how to use these confidently? Have you done them before in questions? Cosine rule and sine rule, and this formula for area. Half AB sine C. So these are the advanced ideas for trigs. So basic, it's two guys, two very popular guys. Pythagoras theorem. Do you know how to use him? Pythagoras theorem says that c squared is equal to a squared plus b squared. The square of the hypotenuse is equal to the sum of the square of the other two sides. Very popular. You're going to use this in the exam. And so ka tua. Right, so that's just short for, that's just trigonometric ratios. So sine, cosine, tangent. And the main idea with the basic part of trigs is that this only works for right angles. Understand? So like if we did in Pythagoras theorem, c squared is equal to a squared plus b squared. That rings, I hope that ringing some loud bells for you, right? Or if we dealing with a right angle triangle again, we can learn about the adjacent side, the opposite side, and the hypotenuse, and work out stuff along that. We're not here today to learn about this right now. I am assuming that you have this knowledge down. So that's basic tricks. This comes in the first part of the paper. Matter of fact, you could see this in question 3 in the exam on Tuesday, right? So that's basic. This is advanced. And then, so what is beginner? Beginner stuff is like knowing your types of triangles. You must know your isosceles, scalene, right angle, or knowing the area of a triangle. Basic area of a triangle is half base by height. You understand? That's basic. Or that all the angles in a triangle add up to 180 degrees. These ideas are tested like in Form 1, and you could still show up, these ideas could still show up in your paper as well, but it will show up tied up into one of these basic or advanced ideas. So you must know your beginner, your basic, and your advanced trigs to be able to do bearings. So cosine rule, sine rule, and this formula for area is a little stronger ideas for trigs because it can work for any type of triangles. It's not limited to right angle triangles. So the cosine rule looks like this. Cosine rule. This should be a refresher for most people, right? Cosine rule looks like this. I'm gonna write it like how it should be in your formula. A squared is equal to b squared plus c squared minus 2bc cos of capital E. That's a situation. I tell my students to look out for like two arms, an angle between the two arms, and then it's like the two arms are holding a stick. So you see it? You can envision like this angle is a face, and these black lines are two hands, and it's holding a stick. And that's kind of like the idea for when you use the cosine rule. But the cosine rule is basically when you have three sides involved in the question and an angle. Three sides involved and an angle. And most of the times you're trying to figure out one of the sides, this side up here. Occasionally it's that you're trying to figure out the angle. All right, so that's the cosine rule, and the sine, remember, it's not only limited to right angle triangles. The sine rule is A over sine A is equal to B over sine B is equal to C over sine C. Or it could be written the opposite way. I could invert this. I could write sine A over A is equal to sine B over B is equal to sine C over C. And this one really talks about the corresponding relationships between a side and the angle opposite it, the sine of the angle opposite it. So, okay, this is one side. Let's call this side A. Then angle A would be this angle opposite. So that's A. That's how triangles work all the time, every time. So like you see the blue line, this is B. I could call that B. Capital B is the angle that's over there. Yeah. And this black line C. Capital C is the angle over here. So once again, this is what I'm doing here. Somebody asked me to do bearings, right? The first thing they asked was bearings. So you may not get much juice out of this. You might not get much bang for your buck if you're not too good in maths, like you're really badly off. So it might be better that you just go and learn algebra and you go and learn all the other basic stuff. You'll be able to capitalize and get more marks that way, rather than you learning the final boss. Yeah, you still need to go and learn off some basic stages. All right, so what does this mean? This means that if I take this side and divide by the sine of the angle opposite, I will get the same value that is equal to the equal to the ratio of another side with the sine of the angle opposite to it. It's a fantastic rule, very, very useful. So we use this rule when we have two angles and two sides involved. You understand? Two angles and two sides involved. It's not that you know two angles and you know two sides. One of these things will be missing. So you might have a missing angle and an angle that you know and two sides that you know, and you need to find the angle. But in the question, you have two angles and two sides involved. In this question, you have three sides and only one angle involved for the cosine rule. So the skill is being able to spot the cosine rule, use the cosine rule correctly. So we're ready now. Back to the question. So that's all, just a little precursor to the question. So this was the question we had. We drew this based off of the information given, and now we're trying to find AC. Well, my spidey sense is telling me that a cosine rule is going to happen because I have this side. Are you seeing it? Let me just draw the triangle over here, right? In one color. Focus, everybody. Stick this board sticking again, boy. Hey, I have class tomorrow, ranting, and your board, you better organize yourself. Oh yes, boy, hotel internet. I'm trying to draw too fast. So A, B, C is like I just drawing the triangle bigger, right? And we remember our aim. What is our aim? Our aim is to find this side. AC. AC. We can see now, you can see if I run out of energy. So we're doing AC. We're trying to find that side AC. What we know that this is 60. Right, guys? We know that this is 60. Let me just get to draw this. We know that this is 60. We know that this is 80. And we know that this angle, this entire big angle here, is 300. We actually know other things too, right? But that feels like what we know right now. Now I'm seeing that I can use the cosine rule to figure out this. Any of you all seeing that I can use the cosine rule to figure it out? Because I can figure out this little pocket angle here. Tysana said this little acute angle in the pocket. And that will mean I have an angle and three sides involved. one of them is missing. This, I can figure it out. That's the cosine rule. Seeing it? So the main skill here is being able to find the value this angle. And that's where the bearing skill comes in. I think that's the trappiest part in bearings, like figuring out these little things. Not so much using the cosine, which is stuff too, but like this is a little more challenging. How do you figure out what that little acute angle is there? What do you all think? It's not that bad. We can figure out what that angle is. We know this is north. So we know that this is 90 degrees. Because this is east, right, of A. B is east of A. So this means this is 90 degrees as well. So this is pointing west at 270, but it's actually going all the way up to 300. So are you seeing that since this whole thing here is 270, but it's going all further than that to 300, are you seeing that I can just say 300 minus 270, 30? Are you seeing that this is 30 degrees? Does that make sense? It makes sense? Seen some people getting some wild stuff there, man. It can't be 210. It can't be those big numbers. It has to be a really small number, right? Because I can go get 270 and go a little 330 again to meet it all the way up to 300, and that means, you see how I figured it out? As simple as that. Now this is the skill here that you'll see in the questions that separates, how to say it, by the sheep from the goat. That's making not be able to figure out the question. So once you get this, the next thing is kind of like substitution. You could just plug it in and you can figure out this angle. I think somebody got it a long time ago. Yeah? That person will get probably real vexed right now. All this waiting, all this talking. So you'll use the formula like this. So you'll have a squared is equal to b squared plus c squared minus 2bc cos of capital E. So a squared, what I do is this is something I tell students to do especially if you're now starting off. Re-annotate. So I'll put A there, capital A here. So I'll draw over this diagram because I want to use the formula as is now. Remember this A, capital A stands for the angle, but I have B there. So I'll redraw a triangle like this. I'll put A there, but if I put A there, I have to go. Remember, triangles go like this. The angle is opposite to the side to keep the same letter. That making sense? And then these two will be B and C. So now I can substitute. I can say A squared, which is what I'm trying to find. AC, the length AC. Okay, are you keeping up with me? This is B, this is C. B and C could be anybody. It could be interchanged. So this could be B, this could be C, or vice versa. 60 squared, you'll get the same answer. 80 squared minus 2 by 60 by 80. That substitution making sense, students? And then cos of capital A, which is 30. And you put in this thing in your calculator, whole. Put it in your calculator. Oh, shucks, I don't have a calculator. Like the thing I forget to bring. Who would I could take faith by? So what usually happens, right? You'll get A squared is equal to, how much will I get when I get this? Somewhere around 1700, 1600, somewhere around there. You need to put this 60 squared plus 80 squared minus 2 by 60 by 80. So how much will I get for the squared part? A squared is equal to something. I'll get 41. Because after you get this, you need to square root it. So they're telling me they get 1686.15. So after you work out this, make sure you work it out, you get that. Then finally, A would be equal to the square root of 1686.15, and that is what they got there, 41.1. And the man say Casio don't lie, so Corey, I believe you. But from the time you use that, this man know he talking about. And that's it. And again, healthy mark, like if you got that question, oh, like 3 marks. 3 marks for that. So the follow-up question would be something, and I feel like closing up shop here. This was a 1-hour session and bearings to jumpstart your studying. I can't believe my voice still suffering the effects of this school. Somebody make this school in Alabama now. I had to come up with like a conspiracy theorist and say this boy because wow. Again, I had the cold since maybe about December, my class, or since around December, it was 7th or so. No, I only had it badly for like 2 or 3 days, but the coughing and little weirdness stay for a long while. It's a new year. It's a new year. All right. So what's the final thing they can ask you with this? The final thing they can ask you with this is like maybe what is the bearing of A from C? What is the bearing of A from C? So let me just show you what's the idea they're looking for. Now, those of y'all who, as I said, you're already kind of there. It's just a polish up. You already know that this is the angle we're looking for, right? The bearing of A from C would be this. So how we figuring out there? Well, when you're in this case, in this situation, in the exam and bearings is something, African sea coconuts. I'll do some research on that, they see more. So when you're in this situation in the exam, you want to look at what the angle is made out of. So you know we could see some of this showing up, some of this idea where you have 2 parallel lines and you have your transversal and you have the corresponding. So we have that in the back of our mind. Yes, but your sine rule is also going to take a play here. So usually, maybe about 80% of the times in bearings question, you'll see the cosine rule pop up first. And then in part C or part 3 or part 4, you use right after, you use the sine rule. It usually comes like that. Sometimes you see the sine rule show up first and then you use the cosine rule. Or sometimes just one rule show up. But usually it's the cosine rule and then you use the sine rule. So we need the sine rule to figure out this angle here, ladies and gentlemen. This angle, this guy, this angle. Those of you all who know the label angles, I'm talking about A, C, B. Ignore this A here. I used that A when I was working on the question. So A, C, B. That angle can be figured out using the sine rule. So watch how the sine rule is a quick, nice, effective thing. So I would say the sine of C over common C, that's this and this, is equal to the sine of this angle. I'll call it B for now. Sine of B over common B. So common B would be opposite. I just figured that was 41.1. Everybody with me? Let's draw for the triangle just to make sure, you know, make sure we only see same page, clear frame. So we found that this angle is 30. We found that this is 41.1. We just found that. We're trying to figure out this angle so that we can figure out the whole bearings now. So we need this piece of the angle, and then we'll figure out, I'll show you how to get this other part just now. But this piece is important first. And we know, we were already told from the beginning, this is 80. So what I'm saying, this is C, this is common C, this is capital B, this is common B. The sine of capital C, notice how I put the thing that I'm trying to find first, right? I put that one first. There's a scale there. And divided by common C is equal to the sine of B divided by common B, which is sine of 30 That's B divided by 41.1. I just found that. And this is sine C, which I'm trying to figure out. Common C is 80. So I just need to bring across this 80 earlier. So my next line would read like this. Sine of capital C is equal to sine of 30 divided by the 41.1 multiplied by 80. Yes, because I'm trying to find the angle. That's why I put the angle on top. Put what you're looking for on top. Very good. So like if I was looking for this side, I'd put C over sine C. Remember I told you all the sine rule could work two ways where we were talking about the sine rule. You could put A over sine A, you could put sine over A. But just make sure all of them line up the same way. So we are here. And when we record this, what do we get? Sine of 30 over 41.1 multiplied by 80. We get some number. That's the sine of C. So C would be, capital C would be equal to the inverse of that number, which is equal to something. So they tell me that number is 0.973. And when I find the sine inverse of 0.973, what do I get? This is us. Hold up. Why are getting two different answers? Or they don't do me this. Make sure your calculator in degrees. So I'm being told that this angle is 76.6. Those who watching in the future, Corey tell me this. Usually he's be correct. But if he happens to be wrong, blame him, right? You notice I didn't press anything into no calculator. 76. Watch this. This camera is real chops, yes. Alright, just now I'm gonna fix my camera. Right. This camera is start moving and thing. So 76.6. So that's this angle, 76.6. Approximately 77. Nobody tell me to wrong it. So we normally use three significant figures when we deal with angles, right? So 76.65 or 76.7. They're saying 76.7 now earlier. 76.7. Yeah, Corey, usually you get everything correct. So you need to think 76.7, right? Earlier, that is 76.7 there. I know it didn't look like it, but that is that. So let's go back to the diagram. So we just figured out that this part is 76.7. So how do we get the 76.6? Let me make up all your mind, man. 76.6. So here's how to know. Remember this was 41.1, we round it off. But use the more accurate thing. Use the other decimals after, and you'd know which one it is, right? That's also a skill. So let me finish off the question. We have to finish on this hour. We have 2 more minutes. So 76.7. How do we get this missing piece here? Well, we were prepared for that long time. Long time we prepared for that earlier. It's a long time we prepared for that. Let's go back to this one. This one is a little more clean. The key to bearing questions is to use the North Pole and to extend if you have to. So this is not, this is 30. I could use a little extension here and figure out some stuff, but instead of doing that, I know this is 30. So then this must be 60. Agreed? This is a right angle. If this is 60, then this guy over here must be 120 because this is co-interior. See how the co-interior come into play again? Or if you couldn't figure out the co-interior, it's 60 and this is 120 over here because it's angle on a straight line, and this corresponds to what we're looking for. So I figured out that this piece is 120. Neat, eh? Is that right? Is that right? Now, when you figure out a bearings question, you feel like they could bring the exam one time. So anyhow, the 120 plus the 76.7, you add up these two, and you will get your bearing of A from C. And just like that, you'll collect the next 2 or 3 marks, and you'll be able to do an entire bearings question. So in this hour, we kind of looked at some of the core things that you need to be able to have a good command of a bearings question. tomorrow, please God, I have a maths and physics class. That's my maths and physics class. And then I have some time I may try to come on and do maybe an next hour of another topic. And then on Wednesday, I would be able to do some topics. Maybe I would do a longer session. That's the day before the exams. And we'll try to do like a couple other topics. We'll try to do more money topics on, but when I say money topics, I mean topics that are, by knowing those topics, you're guaranteed that much more marks. You understand? This is like a final topic. This is a topic, once again, for students who occasion maths already and you're just polishing up bearings. But if you're on the middle to lower level, you want to make sure you have topics like measurement, algebra, relations, functions, graphs, those low-lying fruit, you want to make sure you can pick them fruits so that you can pass the people them exam now. So someone asked for vectors like next time. Yeah, we can do some vectors. We can do some vectors. So it's 1 hour, it's 9:31 here, it might be 8:31 wherever you are. No, or whatever the time is wherever you are. It's 9:31 wherever you are, it's 8:31 here. My laptop time actually saying Trinidad time. So love and blessings, everybody. Excuse me, if you're in my maths class, most likely we'll have class tomorrow, please God, so look out for that. Those of y'all who have Tuesday maths with me, although we have 5 Tuesdays in January, welcome to 2024. Love and blessings. Press like on the video. Those of y'all who first time you're seeing me, my name is Cohen Springer, online teacher. You can reach me for classes and all that stuff at 868, the Trinidad area code. And then you put my personal number down there, 472-4221. I have an online school called the Student Hub. Excuse. All CSEC, keep all those subjects, SEA, available. So you can just WhatsApp this number if you plan on maybe doing the exam in 2025, or you need some help, some lessons for this year's May, June exam, jump on board. We're going to be accelerating. This is the exam season, And that is it, you know. Love and blessings. Later, Delicia, Diana, Maduri, Isha, Chelsea. See my phone that be buzzing up here. Yeah, so this number an admin will be speaking of an admin from the Student Hub. Love and blessings. Keep it. I don't know what to say. Keep it studying. Go and learn the bearings.